Okay, so interesting math fact of the day. 111,111,111 squared, or times itself, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. I don't know why that's so interesting to me, but I thought it was cool. Alright, so we are working on 2.1 and 2.2 today, adding expressions and substituting expressions. Um, in 2.2, we're going to be using expressions and equations at the same time, so you'll see them being used more than once of each. Okay, so hopefully today I won't forget to post your textbook because you need to do questions out of there, but in case I do forget to post it, the questions are here. Okay, so we are working on page 28, A through C, adding expressions. What are the advantages and disadvantages of using one equation rather than two equations or more to represent a situation? So go ahead and copy down this chart here because this chart is going to be important in writing these equations down here. Leanne, Gilberto, and Alana are actually from Moving Straight Ahead, and these are their pledges. And this is what their pledges were per person who pledged them. So if someone gave money to Leanne, they gave $10. If two people gave money to Leanne, she ended up with $20, etc. This is the number of sponsors she gets. Okay. Gilberto got 7 sponsors and Alana got 11. And each of those 11 people are giving him $5.50 a kilometer. Each of Gilberto's 7 sponsors are giving him 2 kilometers per hour, and Leanne, they're all giving her $10 apiece. So question A says, write an equation to represent the money, M, that each student will raise for walking X kilometers. So this is the money that Leanne raised, M for money, and this is Leanne. We're going to write her equation. So I'm going to go ahead and write her equation and follow along for the first one, and if you want to pause the video and try it on your own, you may. Okay. So I'm going to start off with a number of people. Okay. So she got 16 sponsors. Okay. 16 sponsors. From those 16 sponsors, each one of them gave her $10, regardless of how far she ran. Okay, so her total output, her total money is 16 times 10, or you can say $160. There you go. Okay, so this was her equation, 10, but then we multiply it by the number of sponsors she had. Okay. Now, if you want to try Gilberto's on your own, go ahead and give it a try. I'm gonna keep going. But if you want to pause it now, is a great chance to test your own knowledge. Okay, Gilberto had 7 sponsors. Okay, so 7 people all decided to pledge $2 for every kilometer. So this is for walking X number of kilometers per kilometer. Now what you notice is we didn't do that for Leanne because her sponsors just gave it $10 flat rate regardless of the number of kilometers she walked. So Gilberto's equation could be 7 times 2x, or it can simply be 14 x's, 14x per kilometer. For every kilometer, she's making $14 because it's $2 for every one of her 7 sponsors. Okay, Alana will be a lot like Gilberto. She's going to have 11 sponsors, and then we have to write her equation down. Okay, so Alana's 11 sponsors all gave her the same thing, so we have to write her equation down. So Alana's equation is she gets $5 and she gets 50 cents per kilometer. 50 cents per kilometer. There it is. And we can use our distributive property for this. And then this can be simplified like we did the other two. I can multiply these two together. I have 11 people who gave $5 at the start, which means $55, or 11 times 55. And then those 11 people also give 50 cents for every kilometer, plus 11 times 0.5, which is 5.5x. Okay, Okay, number 2 says write an equation for the total amount of money, M total, for the 3-person team will raise for the walkathon kilometers X. So what I need to do is I need to combine all 3 of these items together. Okay, so I'm going to have M total is equal to, well, here's 160 plus $14 per kilometer plus 55 plus $5.50 per kilometer. Now, that's not really what I'm looking for exactly. What we're trying to do is make this easier than have all this crazy mess. These is per kilometer cost. So they're getting $14 per kilometer and then another $5.50 per kilometer. We could just combine those two together. So we can say that those two are going to be 14 plus 5, that's going to be $19.5 for every kilometer this team is raising. Now, the other money that we didn't highlight is not a per kilometer cost. Leanne gets $160 no matter what because she got $10 per person and she got 16 sponsors. Gilberto got $55. Sorry, Alana got $55 from her 11 sponsors right off the bat, and I'll put those two together, and those two make 215 $215 at the start, and that should be the total amount of money raised. So the M total, the money raised total, the money total raised, total is $215 right in the beginning, and then they also get $19.50 per mile with a combination of Gilberto and Alana's per kilometer money raised. Okay, I'm gonna keep going. So if you look at these questions and you're like, oh, Mr. P is just gonna answer these questions, go ahead and feel free to answer them without having to watch it. It may or may not be easier. You may want to try it yourself and then answer it on your own. Okay, B1 says write an expression that is equivalent to the expression for the total amount of money raised by Team A. Write what this equation. Explain why it is equivalent. So for B1, we've kind of already did that. What it's telling us is to write an equation equivalent. So this was our original equation up here, and this is our equivalent equation. So I'm just going to write it like this. I'm going to say 160 plus 14x plus 55 plus 5.5x, 5.5x. Sorry. So, sorry, I can get back to this. So that was the original equation that we came up with, and that's going to be equivalent to what we wrote the second time, 215 plus 19.5x. Got a little ahead of myself there. Okay. What information? Well, we know these are the same because the 160 and the 55 make 215. The 14x and 5.5x make 19.5x. So these are the same idea. What information does this new expression represent about the situation? Well, it kind of gives us a general idea instead of a whole bunch of small parts. It puts it all together. So this is initial money raised. Initial money at start. So this is the amount of money they get even before starting their walkathon, and this is a per kilometer KI, kilometer. That's a per kilometer money raised. Okay. Suppose each person walks 10 kilometers. Explain which expression you would use to calculate. Well, if they're walking 10 kilometers, I'm just going to use this one because I don't want to have to substitute it twice. So this one doesn't change, these two change, but again, why should I substitute it twice when I can substitute it once? So I'm going to use this equation. and I'm going to write it in here. So I'm going to put B3, and I'm going to write $215 plus 19.5 times the 10 kilometers here. I'm going to put that here because that's X, the amount of kilometers walked. So we have 215 plus, I'll move this over one, $195. Sorry, this should be money total. Okay, I'll add these two together, 195 plus, and the total amount of money raised, so the M total, the money total, is $410 raised. That's pretty good for walking 10 kilometers. Now, is this relationship between kilometers and total money raised linear or nonlinear? Well, there's a couple of ways you can do this. One, you can make a quick chart. You can say kilometers and money raised, right? And then you can put 1 kilometer, 2 kilometers, 3 kilometers, maybe 4, just to give you guys a nice pattern. And then you can substitute 1 into here, solve, put your answer, put 2 into there, solve, 3 into there, etc., and see if it's linear or not. Okay. All right. This will probably spill into the second video, but the second video will probably be shorter. But let's go ahead. Actually, I'll stop it here. Go ahead and write down 2.2. I'll stop it. We'll start a new video for 2.2, and we'll answer these questions here on page 29.